Welcome. My name is Okubo Benebo. Sustainability seems an issue everybody talks about, but the powers that be do not care about. Most of these people are heavily invested in fossil fuel resource for energy production, hence their distaste for anything sustainability. But even that is tenable. For after all, whoever does not want to preserve one's assets? Quite rational from every perspective. Yet, many people still focus on sustainability, and daily activities are expected by the many as must reflect sustainability. While some people like to be explicit, others are implicit, as has been the case with farming for food, of which not one episode has focused on sustainability. Yet, the operations of the farming for food, subsistence farming, has been steeped neck deep in sustainability. Even so, yet it is necessary to elicit the manner in which farming for food had engaged on sustainability without being explicit, because such broadcast is not always in the interest of everybody. The fact is that in farming for food, the object has always been to ensure that the most people around the world consume the material contents and benefited from the contents to the extent that world hunger is elevated as is possible without ever becoming a topic of debate on sustainability. Farming for food was never intended to be a knowledge base in which to debate the merits and demerits of sustainability, but rather a knowledge base for humanity of all times to learn and stave off hunger, whether through subsistence farming or in taking a first good step in preparations for commercial farming. In synopsis then, this episode entitled Intrinsic Sustainability in Farming for Food elicits the intrinsic commitment of farming for food to sustainability by the pervasive practices of sustainability without an apparent broadcast, elicits the mindset of the recycle of minerals in its pursuit to up the scientific quality of subsistence farming, and elicits the choices made in the selection of options that are laced with the implicit goal of not aiding in the creating of industrial waste. The driver rationale guiding elicitation of the practice of sustainability implicit in farming for food has the object of highlighting the intrinsically pervasive practice of sustainability for the curious mind and for the buzzword chasers. The approach to the elicitation challenge has been by a step-by-step review of the several episodes published so far, and then highlighting the sustainability practices otherwise intrinsic in the contents of the episodes. The general telltale of sustainability as practiced in farming for food is the orientation to biological systems rather than chemical systems. Over the years, chemical systems have been produced through the use of fossil fuel-based resources. On the other hand, biological systems are simply on the up and coming and are yet to be understood to any significant degree because of the intrinsic aspects of life in biological systems. But biological systems are of sustainability, being characterized by nature to return to nature at end of use and be replicated yet again by nature itself. In this regard, the obvious non-deployment of photovoltaic cell for collecting energy from the sun in alleged sustainability is glaring posture in farming for food from adopting non-biological degradable resources. Photovoltaic cells have a lifespan of 15 years, after which it cannot be recycled as such anymore and becomes an industrial waste, given that it's not biodegradable. Therefore, the absence of use of photovoltaic cells in farming for food positions the orientation to sustainability trust for enduring application as well as keep farming for food out of contributing to the creating of industrial waste, even if unwittingly. To boot, comparatively, farming for food chose the use of biofuels and biofuel burners, which from an engineering perspective has a much longer use lifespan and has near complete recycle for related application. More specifically, farming for food starts off with using methanol produced from apple and orange peels to generate power to the powering of the farms. In this energy project, the design used process equipment of the variant of a storage in an as-is form of previous use or repurposed for the specific application. The significant feature of this improvised energy system as implemented is that unlike the photovoltaic cells, the first use industrial lifespan is 30 years. And that is twice the lifespan of photovoltaic cells. And then it has another lifespan of 30 years. And continuously in repeats until removed from deployment. So right there, sustainability is practiced. Yet, going further into the system's operations, one thing is clear: the raw materials resources used in the energy system, being biological, are invariably recycled. After all, being decomposed from the biotics into the biofuel, a conversion of sorts, constitute a first step recycle, and then being burnt into carbon dioxide and vapor are returned to reconsumable state of matter. Water consumption by plants and humans, and carbon dioxide consumable by plants to regenerate. In the abstract, oranges and apples that can be used to produce yet again methanol for biofuel, or better yet, as the biotics of the post-harvest biotics of subsistence farming, subsequently used in the production of biogas and bioalcohol. Beyond the use of biofuels for power electric generation, farming for food advocates the use of biofertilizers instead of chemofertilizers, or simply fertilizers as commonly called. Even from the get-go, the choice of provisioning fertilizers for farming was by the carefully planned composting of biotic waste. The power was generated from the carefully managed anaerobic digestion of biotic waste, such that only the first two stages, hydrolysis and acidogenesis of the digestion process, were permitted to occur. In the second go-around of the production of biofertilizers, the first-tier process was adopted into an interrupted reactions biofertilizers process, in which one equipment was used, and after the two stages of anaerobic digestion, the anaerobic digestion reactions were interrupted, and the algae cultivation reaction started when algae and the necessary micronutrients were added into the vessel to consume to the contents, to reset the amino acids and nitrates into the forms that plants readily assimilate in an effort to enable the rapid growth of the plants. Even within the biological spectrum of operations, farming for food took measures in at least three means: adoption of automatic controller systems, light disperser network, and adoption of harvesting Gantt chart to minimize the generation of waste. The specific manner by which each method undertook effective waste minimization is different, of course. For the automation controller system, effective waste minimization obtained from the timely execution of tasks and the precision watering of the plant, therefore preventing plants from dysfunction, either from overwatering or underwatering. So the plants were always in the state of near optimal existence and therefore survived and would be fruitful, as was the planned goal. For the light dispersal network system, effective waste minimization obtained from prevention of plants' interactions that often led to diseases between plants that result in the death of plants, which in the case of planting with seeds is equivalent to a waste of use of seed. For the harvesting Gantt chart, effective waste minimization obtained from the synchronized harvesting scheduling that enables the effective managing of the harvesting of several crops that prevents any and all possible oversights of any plant that has the prospect of crop failure. One other approach by which farming for food effects waste minimization, but most exceptionally recycle maximization, is the oblique use of sunken beds for planting. As will be surmised from the planting of the essential crops and complete proteins, the domain of roots functionality is anticipated, and a cylindrical hole dug into the ground and then filled with biofertilizers, with this cylindrical biofertilizer space being the domain for planting the crop, and as such a sort of sunken bed, in contrast to elevated bed as preferred by some subsistence farmers. The use of sunken bed clearly limits the use of the biofertilizers to the domain of plant roots functionality, and hence maximizes the utilization by the plants of the biofertilizers at a product stage of recycle, while also ensuring that the biofertilizers are not mixed into the soil in the areas in which the plant roots would have no use for utilization, and therefore would have been a waste of the usefulness of the biofertilizers. The conclusion that could be drawn here is that farming for food engages in the practices of pervasive sustainability without explicitly advocating such, because the sustainability is simply consequential of the choice of methods adopted for enduring existence. That future generations, endless, may find methods of farming as advocated here applicable through time. Further, that the pervasive sustainability as practiced in farming for food does not focus on only the use of biodegradables to effect recycle of materials, but actually extends to include even the prevention of the waste of recycled material, as well as the maximal utilization of waste in the conservation economy, evident in the use of the biofertilizers. In fact, the task of prevention of waste recycle is taken even further to the extent of preventing the creating of waste, as is the case with the functionalities of the light disperser network and of the automation controller systems. In conclusion then, any assertion of farming for food as being wholesomely fostering sustainability would be entirely tenable. And it's a wrap. And on that note, I say to you, thank you so much for having come to listen to this observation about efforts aimed at alleviating world hunger through subsistence farming by both urban dweller farmers and emergent countries' small farm farmers. You are truly appreciated, and if you would like to get privileged viewer reader information, access podcasts of specialized contents, or access even vertically integrated concepts, then I implore you to join my support club and enjoy that privileged status. Moreover, while still here, do please take a moment and subscribe to the channel as to be informed of the publication of every new episode as soon as it is released. Thank you. Bye. Till next episode.